Alright, this is lesson 35 for 8th grade, and we're talking about similar and congruent polygons today. Once again, my projector is kind of in a bit of a rut, so I'm going to try to get through this quick. Should be fixed by tomorrow, so hopefully we'll get it fixed. Alright, so here's what we want to do today. We want to understand the difference between congruent and similar. We want to identify if we have congruent shapes or similar shapes. And we want to use the concepts of congruent and similar to help us solve some problems. Alright, so let's sum this up here. It says, we will recall that two figures are similar if they have the same shape, even though they may vary in size. So similar shapes we've talked about already. If they have the same shape, they are similar, even if they are not the same size. If they are the same size and they are similar, that means they are congruent, which we will get into in a second. So down here it says A, B, and C are similar. And to see this, we can imagine dilating triangle B as though we were looking through a magnifying glass. So remember, when we dilate something, we make it bigger, but the sides stay proportional. So A, B, and C, they all look like they're the same shape, even though they're different sizes. So we would say that all of these are similar. And to write that, we've talked about that before, we would say triangle A is similar to triangle B, and they're both similar to triangle C. So similar is just that little squiggly line right there. Okay? And it says triangle B is not similar to the other three triangles because it's a different shape. Reducing triangle D or enlarging triangle D will change its size but not its shape. So D is not similar to the other three. And as I kind of got into before, we recall that when figures are the same shape and size, they're not only similar, they're also congruent. So that means that they're pretty much exactly the same. Or at least their sides are all the same length and their angles are all the same as well. So it says all three of the triangles below are similar, but only triangles ABC and DEF are congruent. So these two, although they might be flipped around or reflected or rotated, it does not affect their similarity or congruence. So these two are reflected. This one is, well, if we look at it compared to this one, it's turned around. But I'm not sure why they said it was rotated, but that's okay. Anyway, those transformations that we've talked about before won't affect similarity or congruence. So it can be turned around, it can be moved to a different spot. So these two are still congruent, and then all three of them are similar, even if they're positioned in different spots. Alright? Okay. So when we inspect polygons to determine whether they are similar or congruent, we compare their corresponding parts. So corresponding parts are the things that we would say, well, let's read on here. It says, referring back to the illustration of triangle ABC and DEF, we identify the following corresponding parts. So basically the things that relate to each other is what I was trying to get at. So they say angle A corresponds to angle D, so that'd be A and B. Angle B corresponds to angle E, this one and this one. Angle C corresponds to angle F, C and F. So segment AB corresponds to DE, AB and DE, BC and EF, and then AC and DF correspond to each other, or FD, CA. Doesn't matter what order you say them in. Although notice that when we said AB, we also said DE. So we want to follow that same pattern if possible, which we should. So when they said B to C, we'd want E to F, and then they said CA, so we'd want to say FD, so that they all kind of circle the same way. But you know, it's not a huge deal if we flip the letters around a little bit. So you could have said AC, DF, could have said CA, DF, doesn't matter for me, I guess. But it is easier if we try to keep that same order. Oh. Alright. Now, referring to those triangles again, we actually use these things called tick marks and then arcs for angles. So things that have the same length or the same angle measure will kind of look like this. So these were the two triangles that were congruent. So this little dash right here, or tick mark, says AB and DE are the same length because they both have one tick mark. So those two correspond to each other and they're the same length. BC and EF have two tick marks, so they're equal. CA and FD have three tick marks, so they are equal in length. Notice that angle C and angle F have one arc, they're the same. A and D both have two arcs, they are the same. Angle B and angle E have three marks, or arcs, so they are equal. So we'll notice that the sides and the angles, everything's equal or the same between these two because they're congruent. Over here, this angle is congruent to F, which is congruent to C. H is also congruent to E and B. Angle G congruent to D and A. So for similar objects, the angles will still be the same as the other shapes, because remember the shapes are the same size, not the same size, they're the same shape. So they have to have the same angle measures. You'll notice that the sides are the only things that are not equal to these two over here. So for similar triangles or shapes, the angles will be the same, but the sides will not be necessarily. So congruent, everything's the same. Similar, just the angles match up with other things. Okay? And I showed you this before, but we would say this symbol represents similarity. We would say ABC is similar to triangle GHI, and notice how the order here matters. So we would actually write it like this: ABC, and GHI. Notice how the corresponding parts are matched up here. Angle A and angle G correspond with each other. Angle B and angle H correspond with each other, so they follow that pattern. And when we're naming these congruence and similarity statements, the order does matter, so we want to make sure we get those right. So our congruent symbol takes the similar symbol and just puts an equal sign underneath it. So we would say triangle ABC is congruent to triangle DEF. So ABC, DEF. Once again, corresponding parts. A and D, they correspond with each other. B and E correspond with each other. C and F. So we're following that pattern. Or you could look at it like this. This segment and this segment go together, and then these two segments go together. So we have to go A to B, D to E, B to C, E to F. So the order does matter. This will tell me right. So if we have this statement correct, I could underline C and F, and I should be able to say, okay, angle C and angle F should be the same. Let's check. C and F. Yes, they are the same. How about A and D? Yes, those angles are the same. So the order does matter for those statements. Alright, so here's what we're figuring out here. Similar polygons have corresponding angles, which are the same measure, and corresponding sides, which are proportional in length. So they are not the same length, but they are proportional. That means, well, we'll show you what that means in a second here. Congruent polygons have corresponding angles, which are the same measure, and corresponding sides, which are the same length. So congruent, everything matches up. All the angles are the same. All the side lengths are the same length. So let's use our similar definition to figure this one out. Which two quadrilaterals are similar? So what we need is we need to have corresponding angles, which are the same, and then corresponding sides, which are proportional. So we've got sides and angles in here. We can throw one of these out right away. That would be D. Because in order for something to be similar, they have to have the same shape. Okay? So that one's gone. It looks like it's appearing that these two.
Allison Miller and Haley Yankoviak to the office, please. Allison Miller and Haley Yankoviak.
It appears that these two might be similar, but let's check to make sure. We do have corresponding angles, 100 and 100, 80 and 80, 100, 100, 80, 80. But we want to see if we have proportional sides. That means we could take 12 over 8 and reduce that. That reduces to, if we divide by 4, we'll get 3 over 2. Now, we should be able to do that with our 8 and our 6 as well. If we divide by 4, we can't, because 8 and 6 are both not divisible by 4. We can divide by 2, and we'll get 4 over 3. Okay? So as of right now, it doesn't look like that's going to work out, because these two sides should be proportional to these two sides. Okay? So it doesn't look like A and B are going to be congruent. So let's check out, not congruent, similar. Let's check out A and C and see how that works out. So I'm going to say 12. So this side would correspond to one of these sides. So that would be 12 over 6. Or 12 divided by 6, we get 2. If we go okay, so now we have our other side, 8. That's going to go with one of these forward. So C is rotated around differently, but that's okay. It doesn't affect similarity. So 8 divided by 4 equals 2. So we still get 2. Let me check my time here. Alright, got a couple minutes left. Alright, so it appears that since this side and this side are proportional to this side and this side, and then the other two are the same, that A and C should be the similar ones. I just want to make sure that we've got that right, and I think we do. Should be right here. It says A and C are similar. That's what I would say. And they word it nicely. We're just going to basically there compare our longer sides, 12 and 6, to our shorter sides, 8 and 4. So we should recognize that quadrilateral B was not one that was similar. It did have the same angle measures, but the sides were not proportional with A. Okay? We're going to have to talk about that one quite a bit. Alright. So here we've got triangles are a special shape in math. We have some rules about them as far as similarity goes, and here are a couple of them. Triangles are special in a lot of ways. We use them all the time. If two triangles have proportional corresponding side lengths, then the triangles are similar. Okay? So we call this the side-side-side triangle similarity. Angle similarity. If the angles of one triangle are congruent to the angles of another triangle, then the triangles are similar, and their corresponding side lengths are proportional. Alright, this one says, and we'll memorize those two rules more so in high school, but we'll get into it a little bit this year too. Just want to introduce it. This one says the triangles are similar, find x. So if these triangles are similar, that means their sides are proportional. So this side looks like it goes with this side with this side, and then 3 inches side would go with the x. So if we compare the two blue ones, it looks like we are